What you are seeing is a microanalysis of ground elevation changes along US Highway 1 in the Titusville area of Brevard County, Florida, situated on the western shoreline of the Indian River. This type of microanalysis has become critically important for understanding flooding behavior in swale drainage systems, where subtle changes in ground elevation, sometimes just fractions of an inch, are completely imperceptible to the human eye. Standing on this road, you would never know that the pavement dips by 6 inches over a quarter-mile stretch. But that 6 inches is the difference between a road that drains and a road that floods. What makes this possible is point cloud LiDAR, light detection and ranging. An aircraft equipped with a LiDAR sensor fires hundreds of thousands of laser pulses per second toward the ground. Each pulse reflects off the surface and returns to the sensor, and the precise travel time of that return gives us an elevation measurement accurate to within a few centimeters. Over a small area like this, the result is a dense point cloud, literally several million individual elevation measurements painting the surface of the Earth. With that density of data, we no longer rely on traditional surveying assumptions or rough interpolations between sparse data points. The interpolations become machine exercises, mathematical surfaces fitted through millions of known points, and the precision becomes virtually unlimited. If we needed to resolve elevation differences of less than 1/10 of an inch, the data supports it. This animation steps through quarter-foot increments. Each frame reveals terrain at the next elevation threshold, rising from 5 feet up to 30 feet above sea level. You can watch the road surface, the drainage swales, and the surrounding terrain emerge layer by layer. But understand, this is actually a coarse view. We could refine this to an order of magnitude greater detail if the analysis demanded it. What you're watching for is the low point, the place where rising water would first overtop the road. And with this tool, built in Google Earth Engine, we can identify that location precisely, measure its elevation exactly, and determine the flood stage at which US Highway 1 becomes impassable. This is the new standard in forensic flood analysis. Not estimates, not approximations. Exposed ground truth, one laser pulse at a time,